Hi, everybody. This is Mr. Foley, and this honestly is my favorite topic in AP chemistry. I like the rate laws. I like the math with it. I think it's kind of crazy. I think it's kind of fun, but there's a lot to it, so I'm going to hop right into it. Okay, so first of all, you got to get comfortable with the fact that rate law just plain old looks like this. The rate of something equals a constant K times the concentration of one thing raised to a power, concentration of another raised to a power, concentration of another raised to a power. Now, I use X, Y, and Z and A, B, and C, so you don't think that those are related to each other because they're not. Okay? K is the rate constant, and its units change. Sometimes it's molarity per second, sometimes, and it's all kinds of crazy things. Okay? Rate will be molarity over time. I mentioned that in the last podcast. That's usually how we do rate. It will be with rate laws all the time. Different units for time, minutes, seconds, and hours are possible. It's almost always seconds, though. X, Y, and Z are the reactants, or sometimes catalysts, in molarity. So notice anything in brackets means that it's molarity. Okay? Only aqueous things and gases could possibly be listed here because solids and liquids don't have a changeable molarity. Their molarity would really be their density. Okay? Little a, little b, little c are exponents describing the effect of the concentration. Oops. Get rid of that. On the reactant rate. The options for A, B, and C are 0, 1, and 2. Okay? So first of all, every once in a while, just the plain old letter A will make products. That's going to be called unimolecular. It's called molecularity. It's a vocabulary thing. It'll be in there. So you got unimolecular, bimolecular. Oh, there's two things. Bimolecular. Oh, two things, but they're different. Termolecular. Oh, three things or three different things. And that's it. Okay. So unimolecular, notice how that's got a coefficient of 1. Bimolecular has a coefficient of 2, or bimolecular has a coefficient of 1 plus 1, which is 2. And termolecular could be 3 squared, or 1 and 1 and 1. Okay? Molecularity is essentially how many particles have to collide with enough energy in the correct orientation. Second order has 2 particles collide with each other with enough energy in the correct orientation. So as you go down, it gets harder. Oh, here comes cough. I actually remember to pause my cough. How about that? Second and third order are much harder, much slower, and much less frequent to encounter. Okay, so again, rate is change in concentration, it's in units, over time. K, so rate equals a constant K times that substance raised to raised to an exponent. All right. So this right here, you've got to get super comfortable with it. It is on the equation sheet, but not all of it's on the equation sheet. So if you have your equation sheet out, you can look and see what's missing. The rate law. Rate equals K to the 0 order. That means the concentration has no effect. Okay. And then this has a first power effect, a second power effect. The integrated rate law, so there's a little calculus fun going in here that you can figure out or just kind of learn. So you've got A versus T. So notice how what I like about this is it's written in my favorite way to write an equation, y equals mx plus b format. Make my y look more y-ish. I'm going to try that again. I'm going to zoom this in. I'm going to make it look a little more legible. Y is A equals m. That's going to be my slope. X is this right here plus b. Okay, so the plot for a linear graph is going to be A versus T, Y versus T, and this would be linear. Okay, do you see how this is going to be my Y equals mx plus b? So the natural log of A versus T. Okay, and notice the slope would be negative because it's got a negative here. The slope would be negative as you have negative here. And here I have 1 over A equals positive KT. So that's how you can tell graphically what order a substance is going to be. All right. The half-life, and we'll get into half-life a little bit here. Half-life is constant here, right? So this is going to be 0.693, which is ln2, by the way, if you didn't know your natural logs. divided by whatever that constant is. So you can solve for K by looking at the half-life. All right. Notice how this is amount dependent. This is amount dependent. Okay. All right. So now we've got some other things we have to get used to. The order with respect to A is the exponent. The order is the exponent. Oh, what am I highlighting? Jump. The order is the exponent. All right. The order for the entire reaction is the sum of the exponents. Okay, so all this stuff is going to be, I almost feel like I should do it after we do some of the problems, but here we go. Reaction order, if it's 0, the units for K is going to be 1 over time. Okay, if it's first order, it's going to be 1 over time, which I'm just going to draw this like this. And this is going to be 1 over molarity. I'll call it seconds in this case, right? And this would be 1 over molarity squared seconds, because remember that time's going to be on the bottom, okay? And then we don't have any n. I don't know why I even left that there. I guess I stole it off the internet. Another thing I want to show you is this is the same thing as t to the negative 1. I know you know that. Remember, raising something to a negative exponent just throws in the bottom. So this is going to be molarity to the negative 1 seconds to the negative 1. And this over here would be molarity to the negative 2 seconds to the negative 1. And it's just math. You've got to remember it comes back, and we'll go crazy. But it comes back to you. And if not, we'll teach it to you and you'll get it now. Okay. And it's just given in different formats. All right. We have to be able to determine the order by using tables like this. Okay. Here's my equation. So the rate law is going to be based on reactants. Reactants right there. Okay. So what's going to happen is I'm going to look and see what happens. These are the same. From experiment 1 to experiment 2, the NH2 negative doubles. When that doubles, my little eyeball can tell me that this doubles. Okay? So, oops, I did this in the wrong order, but that's okay. Find order with respect to NH2. So, here we go. So, experiment 1 and experiment 2. So, NH4 is constant. Notice how I put the same. As NH2 negative 1 doubles, right? The rate doubles. 2 to the x equals 2 to the 1. So the order of the exponent is 1. So let's do NH4. Do you see how in this part these two are the same? But as I do this, this doubles. And this also doubles. So in experiment 2 and 3, NH2 is constant. As NH4 doubles, the rate doubles. So there we go, same thing. So we're going to find the overall order. So I've now found that as I'm writing this, I would need to write the rate law. So I would start out by doing rate equals K. It's always going to be K. And NH4 positive in brackets, right? I just found that out. This order is 1. And then NH2 negative, and this order is 1. So the overall order is 1 plus 1, 2. So let's write the rate law, which I already did. Boop, 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 boop. And then this is find the K at this temperature. Okay, the only thing that changes K is temperature. Okay, so what I'm going to do is I now know the rate law is this guy right here. Here's my rate law. So I'm going to plug in everything except for K and solve for it. So I'm going to use equation number 1. So my rate is 1.35 E negative 7 equals K times NH4 positive, which is 0.1 to the first, times NH2 negative, which is 0.005 to the first. Get out my handy little calculator. I'm going to do 1.37 E negative 7 divided by 0.1 divided by 0.005. I get 0.00274. Okay. And oops. So I just showed that. And then that's going to be molarity. So let's do that again. So my rate is molarity per second, right? Equals K times molarity times molarity. See how my molarity canceled? And you see how this molarity algebraically is going to go in the bottom. So that means I get this right there. All right. Let's do more. Another one. Woof. Solve for the rate, find the rate law, and solve for K with units. So rate. Ooh, that's weird. I'll try and rewrite that one. Rate equals K is going to be Bro 3 negative, Br negative, H positive. Okay, and I'm going to figure out the order here. So notice how these are all the same. This guy doubles, and my rate doubles. So that does the same thing. If it does the same thing, that's first order. So Bro 3 negative is first order. Next I'm going to look at, I need to have the other ones stay the same. So let's see here. These are the same, these are the same, this one doubles. So when this is times 2, this is also times 2. So Br negative is the same. That's 1. All right, H positive. I'm going 1 to 4. 1 to 4, those are the same. This is where it doubles. When this is times 2, this is times 4. 2 to what power is 4? That's 2. Okay. Find the rate law and solve for K with units. So I'm going to use that first one again. So I'm going to write rate equals K Bro 3 negative, Br negative, H positive squared. Plug in those numbers. 8E negative 4 equals K, which is what I'm solving for. Bro 3 negative is 0.1. Br negative is 0.1. H positive is 0.1 squared. So 8E negative 4 divided by 0.1 divided by 0.1 divided by 0.1 squared is 8. K equals 8. Okay, so again, if I'm doing the same thing, I have, I'll change my color here. Go black, what the other one was. So I'm going to have molarity per second, right, equals K times molarity to the fourth. All right, so this will kick it down to the third. So I'm going to have m to the negative third seconds to the negative 1. And that's my answer. All right. My seconds to negative 1 here. Find the rate law and solve for K with units. A is never constant. Okay, so I got a problem here. A is not changing here. So I know when this is the same, this is times 4. When this is times 4, I'm going to use my calculator. 0.0064 divided by 0.0016. So this is times 4. Okay, so that means rate equals K. A, notice that was the same, to the first. B to the who's and know's. Okay, so let's take a look here. I gotta have a change here. So I changed A. So what would happen here is when this doubles, and this doubles, this is times 4. Okay, so in this times 4, I'm going to erase this and put it on this side so I can write it the way I want it to. So I'm going to focus on this. This is times 2. This is times 2. This is times 4. So I know times 2 is because of A, right? So I'm kind of I'm exactly factoring this. The other times 2 is because of B. So when B doubled and this doubled, that means it's first order. So find the rate law and K with units. So does that make sense? So I factor it, and whatever that leftover factor is, the times 2 is because of B, and B doubled. And that's it. All right, that's it. I got it in under 15, so woohoo. Oh, I got to find K. All right, let's plug it in. 0.0016 equals K. A is 1. B is 1. Oh, dividing by 1's like kissing your sister. 0.0016. And I'm going to have molarity, per second equals molarity squared. So it's going to be, I'm going to have a molarity 1 over molarity seconds. Molarity to the -1, seconds to the -1. And we're out of here. Toodles.